Number 1, it says to find E in terms of B and D. Well, E is this piece right here, and then B is the entire bottom, and D is this piece right here. So they're asking, what could I say that E is using only B and D? So what could we say E is using only the letters B and D?
B minus D.
Mm-hmm. Yeah, since B is the entire bottom, if we subtract out part D, that leaves us with part E. Very good. Okay. Number 2 says, find an equation that uses only the sides A and D and the angle C. So I'm looking at angle C, and I want to use the sides D and A. So only those 3 variables to write an equation. Okay, well, what is side D to angle C? Adjacent to it, okay? And side A would be the hypotenuse. Okay, so which ratio uses adjacent and hypotenuse?
Cosine.
Cosine. All right, so we're going to have cosine of angle C is equal to adjacent, which would be D, over hypotenuse, which would be A. Okay? Step number 3 says use the letters E, C, and H to set up Pythagorean theorem. So E, C, and H would all be in this right triangle over here on the right side, right? Okay, so which one is acting as the hypotenuse?
C.
C. Okay, so we could write that as C squared is equal to E squared plus H squared. Okay, after we set up Pythagorean theorem, it says solve for H squared. So how could I get H squared by itself?
Subtract both sides.
Mm-hmm. Okay, so then I would be left with H squared is equal to C squared minus E squared, right? Okay, now it says do the same thing, but with letters A, D, and H. Well, A, D, and H would be the triangle over here on the left side, right? So which one's the hypotenuse in this triangle? A. So we'd have A squared is equal to, good. But again, we're supposed to solve for H. So to get H by itself, what am I going to need to do?
Subtract D squared on both sides.
Good. So we're left with H squared is equal to A squared minus D squared, right? Okay. All right. Then step number 4 says substitute one H squared into the other and solve for C squared. Well, if you look at the 2 equations we just wrote, we said that H squared was equal to this, and we also said H squared was equal to this. So what would I then know about C squared minus E squared and A squared minus D squared? They're equal, right? If they both equal H squared, then those 2 things must be equal to each other. So we're going to have C squared minus E squared is equal to A squared minus D squared. And it says once you set this up, solve for C squared. So how would I get C squared by itself?
Add E squared on both sides.
Right. So then we've got C squared is equal to A squared minus D squared plus E squared, all right? Okay. Step number 5 says now substitute for E from part 1. Well, in part 1, we said that E was equivalent to B minus D. So I'm going to rewrite this equation that we just put down, but replace the E with B minus D. So now we're going to have C squared is equal to A squared minus D squared plus, instead of E, I'm supposed to replace it with B minus D. And that E was squared, so B minus D needs to be squared as well. Okay, now it says to simplify. Well, it says all of these terms are squared. What does it mean to square something? Right. So that wouldn't just mean to distribute that square into that parenthesis for B and D, would it? it literally means b minus d times b minus d, right? So if I were to multiply that out, what's b times b? B squared. And what's b times negative d? Negative bd. And what's d negative d times positive b? Negative bd. And what's negative d times negative d? Positive d squared. All right, could I simplify that any further? Right, those are like terms, right? So this would be b squared minus 2bd plus d squared, right? So I'm going to go replace this with what I just found it to be when we simplified. So I'm going to have c squared is equal to a squared minus d squared plus, instead of this, I'm going to replace it with what we just got, which was b squared minus 2bd plus d squared. Okay, anything else we could simplify any further at that point?
No, cross out the d squared and minus d squared.
Right, we've got a negative d squared and a positive d squared, so those should cross out. Right? Okay, doesn't look like there's anything else we can combine though, right? That's where we're stuck. Okay, so we have simplified, just like they asked. Okay, so now last step number 6. Step number 6 over here says, now substitute for d from part 2. Well, if you go look up here at part 2.
Sorry.
No, you're
I
good.
messed up so bad.
No, you're okay. You can go grab another one. So it says, now substitute for d from part 2. Well, part 2 was this one right here, and we haven't solved it for d yet. So let's solve for d. How would I get d by itself in number 2?
Multiply by a on both sides.
Okay. So that means d is equivalent to a times cosine of c.
Yeah.
So I'm just going to go and rewrite this equation down here, but replace any letter d with a times cosine of c. So we're going to have c squared is equal to a squared plus b squared minus 2 times b, but then there's the letter d that we're supposed to replace. So times a cosine of c, which is your formula for law of cosines. So that's where your formula comes from.
That's so long.
Yeah. It is long. But that's why we also have our law of sines. So anytime we can, we want to use law of sines, right? Because it's a lot easier to use. Okay. So that's what our formula for law of cosines is. So law of cosines is c squared is equal to a squared plus b squared minus 2ba or ab cosine of angle C. So that's a capital C in the formula. Okay, so remember, just like yesterday, capital letters are the angles, lowercase letters are the sides, right? So right here, this is set equal to a lowercase c. So does this formula find a missing angle or a missing side? Side, right? Lowercase letters are sides. So I'm finding a missing side. So if you are looking for a missing side, this is what we would use. So this is for finding a missing side. Okay, but we also might need to be able to use this to find a missing angle as well. It's still going to be the same formula. I would just manipulate it a little bit so that I get the part that has the angle in it by itself. So that'd be this part with C, right? Okay, well, this whole part is being multiplied by C, right? It's all one piece. So if I'm trying to get it by itself, then I'd have to move that whole piece to the other side of the equation. So how would I move negative 2ab cosine C? Add it, right. Okay, and then I would then want to move this c squared off of that side, right? Because because I'm trying to get it by itself. How would I move c squared to the other side?
Wait.
Subtract it. So I want to move this part over here to this side, and I want to move this part over here to this side. So you said we would add this one because it's negative. We would subtract this one because it's positive. Okay? So then I would have 2ab cosine of c on the left, now that I've added it, is equal to a squared plus b squared minus c squared, because you guys said we would have to subtract c squared to move it to the other side, right? Okay, now I am trying to get c by itself, cosine of c. How would I get rid of that 2ab in front of it? Divide. So I have to do that on both sides of the equation, right? So the 2's are going to divide out, the a's, the b's. So I'm left with cosine of c is equal to a squared plus b squared minus c squared all over 2ab. So same formula, we just move some things around, and this is the one I would want to use if I'm trying to find a missing angle.
So when did it turn to 2ab instead of negative 2a cos c?
It was all still there. It just became positive when I moved it to the other side. Okay, and then we can't divide by cosine. To get rid of cosine, you take the inverse, right?
Can we just change the parentheses to just ab?
Yeah, I just b times a times b. It doesn't really matter the order. So a times b or b times a, it's like 3 times 2 or 2 times 3. You get 6 either way. So the order of the letters doesn't matter. If you prefer it the other way, you can keep it flipped the other direction as well.
Wait, dissolving you do the inverse of cosine?
Yes.
Cosine negative 1?
Like what we did yesterday, but for sine. Okay, so same formula, but one is set up to find an angle, one is set up to find a missing side. All right? So just like with our law of sines, there are certain cases where you would want to do this. The cases in which you're going to want to use law of cosines is when you don't have that pair, right? We said for law of sines, you have to have a corresponding side and angle pair, right, to put in one of your ratios. So maybe they don't give you any angle at all. So in the problem, all they give you is the sides. So that would be the case of side theorem or property. Or maybe they do give you one angle, but they don't give you the side across from it, right? Then you are stuck. So that would be the case of side, angle, side. They give you the sides on either side of the angle instead of the side across from it. So if either one of these occur, this is when we have to use law of cosines. Okay, I know just by looking at those formulas, we're not going to prefer to use law of cosines, right? We prefer to use law of sines. But in these two cases, we won't have a choice. This is the only time you have to use law of cosines, is if you have either one of these two cases. All right? So the main thing to notice here is your missing side must be opposite of the known angle. So yesterday we wanted the known angle and side across from each other. Here you want the missing side across from a known angle. So opposite of yesterday. Okay, so let's try applying this. So example number 1 says solve the following triangles, round all angles to the nearest tenth and side lengths to the nearest hundredth. Make sure you are in the correct mode in your calculator. All right, so here's our triangle. I'm going to label my vertices. All right, and we are told here that side A has a length of 8, side B has a length of 19, and side C has a length of 17. So what case do we have here? Side, side, side. So this is why we wouldn't be able to use law of sines, right? Because I don't have an angle to set up in a ratio. So we got to use law of cosines. Okay. I know all the sides, so obviously we're not looking for a missing side. We're looking for a missing angle, right? So if you look back up here and you're trying to decide what formula, that would be this one over here, right? Because that's the one that helps us find a missing angle. Now, it doesn't matter which angle you find. However, I want to remind you guys, if you want to get to use law of sines for everything else, which you probably do, because we don't want to have to use this long formula every single time. Remember, we said yesterday the only thing that law of sines is not able to find is a what? Obtuse angle. Okay? So if I'm going to have to find one using law of cosines, let's make sure we don't have to do it again, right? So what would be the biggest side in this triangle? B, right, the 19. So if I have an obtuse angle, then it's probably angle B, right? Because it's across from the biggest side. So I would probably want to use law of cosines to find that angle. So that way I don't have to worry about it later down the line if I want to switch to law of sines. Okay, so for my formula, we take cosine of the angle that we're looking for, which for us we said we want to use it to find B, since it might be obtuse, is equal to, now you're going to use the ones that are beside your angle. So the ones beside your angle are the 8 and the 17, right? So that's like your A and your B, or your first two values here. So you'd have 8 squared plus 17 squared minus that last number is the one across from your angle. Remember up here we said your missing side or your missing piece needs to be opposite of your known angle. Well, we have vice versa here. We have a known side across from our missing angle. So our known side is 19 all over 2 times our two sides that are next to the angle, which were 8 and 17, right? Okay, so we're trying to find B. How did we say we get rid of cosine? Inverse. So in my calculator, I'd put cosine's inverse of 8 squared plus 17 squared minus 19 squared all over 2 times 8 times 17.
Isn't the formula over 2AB?
Mm-hmm.
Wait, I got an error.
Yeah.
To find angle B.
Oh, B.
Yeah, but
Okay.
Oh, yeah.
Okay, guys, remember I said that we want to find the obtuse angle. So we didn't just pick any random one, right? We picked angle B because we said B has the best chance of being obtuse, right? Okay, the variables that we use here, A, B, C, those are just placeholders, right? They could have used X, Y, and Z for all we care here. This could have been X, Y, and Z, and this would have been X and Y, okay? They do not need to match your picture, all right? You have to put the correct pieces in the correct place. So, since I'm looking at angle B, A and B from your formula, or if we're calling them X and Y from your formula, have to be the ones beside the angle that you're looking for. So you have to put 8 and 17 here. Okay?
No, I think I understood that. It's just that we put it into the calculator wrong, so it gives an error.
Oh, okay, so you just mistyped it. It wasn't that we used, is that what you did? Oh.
Oh,
Okay.
Wait, what? How do we
I
do
don't
this?
know.
I'm just
Oh, so
getting
you
a
have to
What?
put it on top of the list.
Wait, bro.
So we have to do the
You
obtuse
cannot
angle?
do that. Oh, I have to?
If you don't, you might still have, you're going to have to use law of cosines later on. So I'm trying to save you some trouble. Yeah.
Wait, where do you do that fraction?
All right, so alpha y equals enter. All right, so what did we get for angle B? Once you guys got it typed in, right, what did you guys come up with for angle B?
91.68.
All right.
What?
So 91.685. I think it said for angles we could just round a tenth, right? Okay, so 0.7?
Yes.
Okay, perfect. So 91.7.
Wait, okay.
Okay. So you still have to find 2 more angles, right? Okay, the reason that we chose to do this one first is because there was a chance it was obtuse. Did it end up being obtuse? Yeah. That's why we did this one first, because if it's me, I don't like using this formula as much as I like using law of sines, right? It's a little bit easier to set up law of sines. So, now there's no more obtuse angles. You can only have one obtuse angle in a triangle, and we've already found it. So, to find everything else, if you want, you can just use law of sines. So, now I have a matching angle and side, right? We've got 91 and 7. So, I'm going to set it up as sine of my angle, 91.7, over my side, 19. And then I can set that equal to whichever one I want to find next. Let's say we want to find angle A now. Okay? Then I could do sine of angle A over what side A? 8. And then I can cross multiply. So I'd have 19 sine of A equals 8 times sine of 91.7. Okay, and then what should we do? Divide by 19. And then how do I get rid of sine? The inverse. So sine's inverse of 8 sine of 91.7 all over 19. So what are we going to get for angle A? Good. Okay. So now I know angle B and I know angle A. What could I do to find angle C? Perfect. So angle C would just be 180 minus the 2 we know. So what are we going to get for our angle C?
63.4 degrees.
Good. All right. Okay, let's do another one. Okay, so I've got my angles here. And this time we're told angle A is 115 degrees. Side B is 15. And side C is 10. All right, so what case do we have this time? Side angle side. Okay, so that means I don't have any pairs, right? I don't have a pair of a corresponding side and angle. So I can't use law of sines. I got to use law of cosines, at least at first. Okay, but I probably want to find a missing side that corresponds, right? So that we can use law of sines after this. So which side would I need to have so I could do law of sines? Right. So I'm going to look for this using law of cosines. So this time I'm looking for a side instead of an angle. So if you look back up here, that means I'm going to use this formula. Okay? All right, remember, the letters don't necessarily matter, right? It could be any letter. We just apply what it is we're doing. So we're looking for side A. So I'm going to have A squared is equal to, I do the sides on either side of my angle. So what sides are on either side of my angle?
15.
Right? Perfect. So I'll do 15 squared plus 10 squared minus 2 times those two numbers. So 2 times 15 times 10, followed by cosine of our angle. And what was our angle? 115. Okay, But I'm not looking for a squared, I'm looking for a, right? So how would I get rid of a square? Take the square root. So I'm just going to type all that in my calculator under a square root.
Yeah, I know how to do it.
So what is the square root of 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115?
21.26.
Good. Perfect. Okay. And now that I know that that piece is 21.26, if you want, now you can use law of sines. You don't have to use law of cosines anymore because you've got a match, right? Okay, so if I did want to use that, then now I would say sine of angle A, which is 115, over 21.26. And then I can look for either one of the other angles because angle A was 115. It was obtuse, so there's no more obtuse angles. So I could do either one. Maybe I look for B. Okay, and what was the length of side B? 15. So this is what's going to go in my proportion. So I've got 21.26 sine of B is equal to 15 times sine of 115. Then what should I do?
Inverse?
Not yet.
Oh.
First I have to divide, yes, and then we'll take the inverse. Okay. So what are we going to end up getting for our angle B?
39.75.
So that would round up to 39.8, okay? So I'd have 39.8 degrees. All right, and then I'm still missing one thing.
The angle C.
Okay, and what could we maybe do to find angle C?
Add them up and subtract them from the B.
Right.
25.2.
So 180 minus the 2 we know.
What?
So what did we say we would get for angle C?
25.25.
25.2.
25.2.
Yeah, we should only have one single decimal. So,
Well, I said 39.75.
okay, yeah, I think it said up here, yeah, it just wanted us to do the tenth, so that's why we have different decimals. That's okay. All right, and you said we would get what when we subtract?
25.2.
Okay. All right. So, basically what we're getting at here is you do not have to use law of cosines to find everything, but sometimes you're going to have to use it to find the first piece, just because law of sines can't find an obtuse angle, right? And you also have to have a pair to get it started. All right, so let's flip it over on the back. They've got 2 word problems for us to look at. Okay, so first one says, the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as shown in the figure below. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? So in this picture, what piece am I looking for exactly? H. Yeah, we're looking for H. Okay. All right, and based on the information given, what case would we say this is? SAS. So that means I'm going to have to use law of cosines. Okay, so I'm looking for H. Is H a side or an angle? Side. So I'm going to use the formula for sides, which is going to be H squared is equal to your A and your B in that formula, remember, are the sides on either side of the angle you know. So what are the sides that we're going to use?
43 and 60.
Right. Okay. So we've got 60 and 43. Oops, not degrees, but square. Okay. Minus 2 times those two numbers. Times cosine of our angle. And what's the angle we know? 45. All right, and I want h, not h squared, so what do? Take the square root. So what are we going to get for h?
I got
42.43? Yeah, okay. All right, perfect. So we can say the pitcher's mound is 42.43 feet from first base. 0.4 what? Okay, let me see.
Could be an order of operations problem. And in parentheses.
It might be.
It should work.
Yeah, it shouldn't change the value any. I'm wondering if your float is set funny. Oh, well, yours would have been 4.2, so it's not major off. It's 1/100th off.
Well, no, it's 4.3. You got 4.2.
Oh, the number in front. I was looking at your decimals. I didn't even notice that part.
Wait, did I put in the wrong? No, it's okay.
Oh, I think I wrote it on the screen wrong. I think I wrote it backwards.
Oh.
Yeah. No? Is that right? 43.42? Yeah. And I wrote it backwards?
No, wait, I got 44.43.
Oh, you did?
It really is.
Okay, let me see. Let me retype yours then. Second square root of, we've got
Are you in the right mode?
43 squared plus 60 squared minus 2 times 43 times 60 cosine of 45. Oops. Cosine of 45. Okay, I don't know. That's weird.
It's really big.
Yeah, that is strange. Okay. All right. Last one. Number 4. This one says that a ship travels 40 miles due east and then changes direction. When the ship has traveled 30 miles at this heading, it's 56 miles from its point of departure. Describe the bearing from point B to point C in a sketch below. Okay, so I'm going to draw myself a little picture. Here's my ship. Okay, it is sailing 40 miles east. So it went this way 40 miles. Okay, and then it said all of a sudden it's going to change direction. It does not say which direction it changes to. It could maybe start going north. It could go south. It could go southwest. We don't know, right? We don't have any idea. So I'm just going to draw a line showing that it changes direction somewhat. So maybe it starts going like kind of this way. Okay, but it says it travels that way for 30 miles.
56.
What?
Yeah, it's 30.
Yeah, 30. Okay. And then wherever it ends up, it says that now it's 56 miles from where it started, right? So from its starting point here to where it is now, so this line is 56 miles. Okay? Okay. It says describe the bearing point from point B to C. Since we didn't label ours with letters, all it's asking here is when we change direction, what was the angle? Okay? So this just means what is the angle where the direction changed? Okay, so I'm looking to find this angle here. That's what we're looking for. All right, so what case do we have? Right? So that means we're going to have to use law of cosine. Okay, and we're looking for an angle. So that means we're going to do cosine of our angle. You can call that angle whatever you want to call it. Doesn't matter. Is equal to, okay, remember we're going to do the sides on either side of our angle. So if I'm looking for this angle, the sides on either side of it are these two, right? So that's my 30 squared plus 40 squared. And then I do minus the one across from it. The one across from it is, right? All over 2 times those first two numbers we used. All right, and I'm trying to solve for c, so how do we get rid of cosine? Right. So what do we end up getting for our missing angle here? Okay, so just with that round to what? 0.4, you said 3.6, right? Okay. All right. So the angle is 105.4 degrees. All right.